Hello and welcome back to Curiosity Lounge. Before we start, hit that red subscribe button so that you never miss out on any of our videos. The James Webb Space Telescope, JWST for short, is shaping up to be one of the most significant breakthroughs for humankind regarding space observation. Being far more powerful than all other space telescopes ever launched by humans, the scientific community has high hopes. It will enable them to study very distant objects in space, as they have never been able to do. One of the objects the JWST will study is Proxima b, to see whether artificial alien lights are coming from the planet. Yes, you heard right. Scientists want to know if the lights coming from Proxima b are due to aliens. What will the JWST see when it focuses on the exoplanet, and how does it affect you? Join us as we dive into the James Webb artificial lights discovery on Proxima b that will change everything. Exoplanets dot the universe and contain lots of secrets. These are any planets located beyond our solar system. Most of them orbit other stars, but free-floating exoplanets, called rogue planets, orbit the galactic center and remain untethered to any star. While exoplanets are plentiful, most of the ones discovered so far are in a relatively small region of our galaxy, the Milky Way. There are more planets than stars in the galaxy. By measuring exoplanet sizes using diameters and masses using weights, scientists can see compositions ranging from very rocky, similar to the Earth and Venus, to very gas-rich, like Jupiter and Saturn. Exoplanets are made up of elements identical to those of the planets in our solar system, but their mixes of those elements may differ. So you can have some planets dominated by water or ice, while others are dominated by iron or carbon. Astronomers have identified lava worlds covered in molten seas, puffy planets the density of styrofoam, and dense cores of planets still orbiting their stars. The first exoplanets were discovered in the 1990s, and since then, thousands have been identified using various detection methods. However, it is pretty rare for astronomers to see an exoplanet through their telescopes, the way you might see Saturn through a telescope from Earth. That's called direct imaging, and only a handful of exoplanets have been found this way, and these tend to be young gas giant planets orbiting very far from their stars. Since these exoplanets are hard to spot using existing telescopes, scientists have to use indirect methods to detect them. One indirect way is by measuring the dimming of a star that happens to have a planet pass in front of it. This is known as the transit method. Another method used to find exoplanets is monitoring the spectrum of a star for the telltale signs of a planet pulling on its star and causing its light to subtly Doppler shift. Space telescopes have found thousands of planets by observing transits, the slight dimming of light from a star when its tiny planet passes between it and our telescopes. Other detection methods include gravitational lensing, the so-called wobble method. Detecting exoplanets is tough, but studying them after detection is even harder. For this reason, astronomers have not been able to explore one of the most popular exoplanets, Proxima b, as much as they wish, despite all of the great stuff they suspect it is concealing. For example, does the exoplanet host alien life? Now, they have a new tool at their disposal, the James Webb Space Telescope. The JWST isn't the first telescope to be put in space by humans. NASA has a long history of using powerful observatories launched to space to study the universe. One of the most iconic and powerful is the Hubble, which has faithfully delivered stunning images of different parts of the universe over several decades. However, the JWST is more powerful than the Hubble by many magnitudes and also more expensive. At almost $10 billion, the JWST is the costliest telescope ever launched. It is also the most complicated, with several parts being designed to fold up. It was necessary to fold them up so the telescope would fit on the rocket launching it to space. Compared to the Hubble, the JWST is located very far away. The former orbits the Earth at about 350 miles, while the latter rotates about the Sun at a distance of about 1 million miles from the Earth. This means NASA can't send in astronauts to repair or reconfigure the JWST after launch. Thanks to its more giant primary mirror that measures 6.5 meters across, the JWST can capture objects that are billions of light years away, in effect, taking us back in time. The JWST will allow us to take baby photos of the universe because we can now get nearer to the Big Bang as much as possible. The new telescope uses infrared to pick up signals from heat-emitting objects many miles away. To protect the Space Observatory from interference from the heat of the Sun and Earth, NASA placed a shield under the telescope. The shield, which contains 5 layers, is so large it could cover up a whole tennis court. NASA has unveiled a mosaic of the first images captured by the JWST, representing the early stages of the telescope's 18 main mirror segments properly aligning before it reaches its full potential. While the image is admittedly blurry, it is a good starting point in the long process of adjusting JWST's mirrors to take ultra-sharp photos of the distant universe. The 18 points of light that you see in the image all represent the same star, known as HD 84406, seen by a different primary mirror segment. Collecting the light used to generate the image mosaic took about 25 hours. That's all for today. I hope you liked the video. If you did, make sure to hit that like button and subscribe to the channel so that you never miss any amazing video from us.